Meet Jonathan Bird, one of the world's top underwater nature cinematographers. Traveling the world on assignment for all the major networks, he is an Emmy Award-winning authority on the underwater world. In freshwater or salt, reefs, wrecks, or caves, Jonathan documents the world beneath the waves. Welcome to the Blue World.
The sea snake is an animal surrounded in mystery, known for its incredibly powerful venom, but not much else. Just how dangerous are these marine reptiles? I've traveled to Queensland, Australia on a quest to learn about sea snakes.
Here on Australia's Great Barrier Reef, sea snakes are fairly common. Let's go see if we can find one.
I hit the water, grab my camera, and head towards the sea floor. Today I'm diving a little seamount called a coral bommy. It's a mini mountain of coral sticking up from the bottom, but not quite reaching the surface. Near the top of the bommy, thousands of small fish feed on plankton passing by in the current, but they stay close to the reef because they're being watched by a big school of jacks who are on the prowl for food themselves. The bommy is covered in healthy coral that provides lots of nooks and crannies for the fish to hide if they need cover. On the other side of the bommy, a large school of snappers are also looking for something to eat and keeping a safe distance from the jacks. As I swim along at the base of the bommy, I'm keeping my eyes open for a snake-like animal. The coral looks healthy, and a spine-cheek anemone fish gives me a quick glance from the safety of her host anemone. But I keep scanning the bottom, and at last I've found my quarry, an olive sea snake, the most common species around the Great Barrier Reef. It's swimming along the bottom doing the same thing everything else is doing, looking for food. The sea snake is closely related to a land snake, except it's adapted for life underwater. When a sea snake flicks its tongue, it's getting rid of excess salt secreted by special glands in its mouth. Sea snakes live exclusively in the ocean, but since they're reptiles, their kidneys can't deal with too much excess salt in their blood. A sea snake gets around with a flattened section of tail that looks like an oar and serves as a fin. It looks just like an eel when it swims, undulating its body and getting propulsion from that flattened tail. Although sea snakes prefer to eat eels, shrimps, and fish, these snappers aren't at all afraid of the sea snake because they're way too big for the sea snake to bite. This snake is heading for the surface to grab a breath of air. A sea snake, just like a land snake, has lungs and must breathe air to survive. It can hold its breath up to 3 hours during a dive. Recent research has shown that some sea snakes can also absorb a little bit of oxygen directly from the water through their skin, which is probably why a breath can last so long. After spending a minute at the surface breathing, the sea snake comes back down to the bottom. It's poking around looking for holes where it might corner a fish or shrimp. It sticks its head into the holes, hoping to get lucky. The sea snake is most closely related to the cobra on land, and its venom is quite similar to cobra venom, but considerably more potent. If it manages to grab a fish, the venom will kill it in seconds. Sea snakes often take a rest on the bottom, sleeping as they hold their breath. I use the opportunity to sneak up on one. In spite of their fearsome venom, sea snakes are very timid and not particularly aggressive. Although this one is obviously not thrilled about being picked up, it doesn't try to bite me. And when I let it go, it just swims away. I find another one and I can't resist the opportunity to show the flattened tail section to the camera. Swim, be free!
Although the sea snake is one of the most venomous animals in the world, you're not very likely to be bitten by one. And the reason is because they just can't open their mouths very wide. In fact, they have a hard time even getting the tip of my finger into their mouth. In fact, the only place you can really be bitten by a sea snake is on a thin little fold of skin, like between your fingers or maybe on your lip.
There are 62 known species of sea snakes, and they live all around the tropical Indo-Pacific. I found this banded sea snake in the Philippines. They like nice, warm, tropical water because they're cold-blooded like all reptiles. If the water gets too cold, they get lethargic. So no matter what you might think of snakes, sea snakes are timid and shy animals that represent almost no threat at all to people, even though they produce some of the most powerful venom in the world. Many creatures in the ocean survive by forming relationships or partnerships with other creatures. Perhaps the most famous is that of the anemone and the anemone fish, sometimes called a clownfish. An anemone is an invertebrate that looks like a carpet with stinging tentacles. It's basically a jellyfish that can't swim. It stings and kills fish to eat with these tentacles. But this fish, the clownfish, lives in the anemone's tentacles without injury because it's coated with a special slime that tells the anemone not to sting. The anemone provides protection for the fish. This is a perfect example of symbiosis.
The word symbiosis comes from a Greek word that means living together, but it refers to creatures that have a relationship, not just the ones that are living together.
In the case of the clownfish and the anemone, they do live together. This is how most people think of symbiosis. But take the example of the cleaning station. At a cleaning station, one kind of fish gets cleaned by another, such as this manta ray being cleaned by a bunch of wrasses. It hovers over the reef and the wrasses come right over to pick the parasites from its gills. This is symbiosis, but the two animals definitely don't live together. And that's not the only thing confusing about symbiotic relationships.
Although we tend to think of symbiotic relationships as being beneficial to both parties, that's not always the case.
Take the case of the remora. A remora is a fish with a suction cup on its head that allows it to stick to larger animals like sharks, dolphins, and turtles. The remora survives by mooching food scraps and a free ride from its host. They may provide some cleaning services to their host, but for the most part, they seem to be freeloaders. This is definitely a symbiotic relationship, but it's really only good for one party. If the remora were to harm the host in some way, you would call it a parasite. If the remora merely helps itself without harming the host, then this would be called a commensal relationship, or commensalism. The best kind of symbiosis is called mutualism. This is where both parties get something out of the deal. For example, take this hermit crab. She has a garden of small anemones on her shell that she carries everywhere she goes. The anemones give her protection from predators like octopus because their stinging tentacles pack a punch. But the anemones have a great life living on her shell because they gather some of the scraps from her messy eating and they travel around with her to the next meal. Since the hermit crab uses an old snail shell for a home, she needs to find a larger shell every once in a while as she grows. When she finds one, it's as simple as hopping out of the old shell and into the new one. But what to do about the anemones? The anemones are so important to the hermit crab that she must also move them to the new shell. Without them, she's defenseless. Slowly, with a combination of tapping on the anemones and peeling their edges, the hermit crab convinces them to release their grip. Only the crab knows how to coax the anemones into letting go. They will not submit to any other creature pulling on them. Once the anemone lets go of the old shell, the hermit crab deposits it on her new shell. She simply plops it in place and holds it until the anemone grabs on. The anemone will then crawl around on the shell and find a good spot all on its own, while the hermit crab turns her attention to working on the next anemone. "15 minutes later, with the anemones planted on her new shell, the hermit crab has completed her move. She leaves her old shell for the next hermit crab a bit smaller than herself. Another crab has a different symbiotic strategy for survival. This decorator crab grows living sponges, hydroids, algae, and tunicates on its body to create camouflage. When the crab holds still, you will never see it against the similar background. Only when it moves does it give itself away. In the ocean, perhaps the animals most commonly involved in symbiotic relationships are shrimp. Shrimp are found associated with sea cucumbers, sea urchins, sea stars, crinoids, nudibranchs, anemones, coral, you name it. They're everywhere. Why? Well, because they make great snacks. Fish love to eat shrimp, so shrimp need to be clever to keep from becoming lunch. Out on the sandy seafloor of the Philippines, a fire urchin slowly makes its way across the bottom, feeding on algae. The urchin's venomous spines protect it from most predators. On top of the urchin, a pair of Coleman shrimp ride like first-class passengers. The shrimp have used their claws to clear the spines off a little spot they call home. This is a commensal relationship because the shrimp get protection from the urchin, but they don't offer anything in return to the urchin. Neither do they harm the urchin, so they're not parasites either. Another shrimp, another free ride. This Spanish dancer is a large nudibranch, a snail without a shell. It's about the size of your hand. On its back rides an imperial shrimp. The shrimp survives by eating the nudibranch's poop. It gets a free ride and a meal from the nudibranch, but it gives nothing in return. Here's a shrimp with a little more to offer. This shrimp lives with a goby, a small fish, in a burrow in the sand on the sea floor. The shrimp works hard to keep the place clean and tidy, constantly arranging the rocks at the entrance and shoveling out the sand that gets inside. Why do all this work for the goby? The shrimp needs someone to stand guard. While it works, the shrimp keeps one antenna in contact with the goby, while the fish keeps its eyes peeled. If the goby moves, the shrimp retreats. This is classic mutualistic symbiosis because both animals get something out of their relationship. High above the shrimp's head is a much larger animal, a whale shark the size of a bus. Swimming around it are a few fish called jacks. These fish are using the whale shark as a bodyguard. They know that nothing will dare attack the whale shark, it's too big. So if they hang around, they're safe too. The whale shark eats only plankton and tiny fish, so the jacks are safe from the shark's humongous appetite. These are only a handful of examples of the symbiotic relationships in the ocean. There are thousands of different animals all working together to survive, and it's one of the things that makes the blue world so exciting to explore.
Don't go away. Jonathan is about to head underwater at night to learn how coral reefs spawn.
Coral reefs are amazingly beautiful underwater sculptures that grow in tropical waters and provide essential habitat for fish and invertebrates, as well as form an important part of the tropical ocean ecosystem. Some coral, like this bushy gorgonian, may look like a plant. Other coral, such as this brain coral, looks like a boulder on the sea floor. But coral is alive, and it's an animal. Look close enough and you'll see hundreds of little mouths, such as the ones on this star coral colony. Each mouth belongs to an individual coral animal called a polyp. Corals are related to jellies, so think of a coral colony as hundreds or thousands of tiny jellies all clumped together. Like jellies, coral has stinging tentacles to catch prey, which it mostly does at night. But unlike jellies, corals grow attached to the bottom and often create a hard skeleton to hold themselves down.
This begs the question, how does an animal that can't move reproduce and make a new colony in a different place?
I'm on a mission to document how coral reproduces.
So I've come to Bonaire, one of the greatest places in the world to learn about coral spawning.
Biologists have been studying coral reproduction here on Bonaire for more than a decade. Bonaire is an island in the southern part of the Caribbean near Venezuela. It's a beautiful place full of Dutch architecture because it's part of the Netherlands. The rocky windward shoreline is rough, desolate, and pounded by crashing waves. But the other side of the island is calm and tranquil, where it's protected from the trade winds. It's here that I'll be diving to observe the coral.
Coral reproduction is not the easiest thing in the world to observe. That's because coral reproduces by spawning. It only does it at night, and it only happens a couple nights per year.
I've come to Bonaire a week after the full moon in September, when the corals are predicted to spawn.
Why a week after the full moon? Well, it has to do with the tides. You see, during a full moon, you have what's called a spring tide. That's when the high tide is really high and the low tide is really low, and you have a huge amount of water movement between those two tides. A week later, you have what's called the neap tide. That's when the high tide's not quite so high and the low tide is not quite so low. So you have a smaller amount of movement between the two tides. Less water movement means less current. And less current means that the eggs from the coral have more time to float around in the water and get fertilized before the current takes them away.
As the sun sets, I prepare my gear. Soon I'll be heading out for a night dive. The corals spawn under the cover of darkness.
Well, let's go see what's happening on the reef.
I head down the steps of the dock at Captain Don's habitat. Cameraman Tim and I are diving from the dock because the reef is only a few hundred feet offshore. We can do as many dives as we need. Down on the reef, I start hunting for signs that the coral might be ready to spawn. It's pretty dark. I can only see as far as my flashlight beam. I'm looking at each coral head closely. If a coral colony is getting ready to spawn, the polyps will be swollen with the eggs they're going to release. These don't look ready. Movement catches my eye. A spiny lobster is walking down the reef slope, so I take a few minutes to watch. The spiny lobster has no big claws like the lobsters in New England. Instead, its long antennae are covered in sharp spines for protection. Nearby, an octopus is on the prowl, hunting for dinner. I follow along with my bright video lights, but it doesn't take long for the octopus to decide that I'm not helping its chances of finding a meal. It gives me the slip with a squirt of ink as it jets away into a hole. After 3 hours underwater with no sign of imminent coral spawning, Tim and I decide to call it a night. We're tired.
Well, that was a long night, but no spawning tonight. So, try again tomorrow.
The next day, I spend a little time touring around the island to see the sights. First, a stop at Lake Godemere to see the flamingos, for which Bonaire is famous. Their pink color comes from the shrimp they eat. Next, I swing down to the incredible Cargill Salt Works to see the huge piles of salt created by drying out seawater in vast, shallow pools. And of course, to downtown Kralendijk for a few gifts at a colorful gift shop. But then it's time to head back to the dive shop to prepare for the night dives. Tim and I examine the predicted coral spawning times published by the Bonaire National Park.
Okay, tonight on the 29th, it is predicted to be the peak spawn, okay? So you'll notice we have almost all of the species.
If we can't nail it tonight, we'll never nail it.
No, tomorrow night, the star corals and the brain corals should still be spawning. In fact, tomorrow night is the peak for the brain corals.
After dark, I suit up again for another long night.
Well, tonight's supposed to be the peak spawn. I'm hoping for a great show. Let's check it out.
As I swim out to the reef, I'm joined by a school of gigantic tarpon. These big silvery fish are as long as a bicycle and have learned to use divers' lights to find smaller fish to eat. They follow Tim and I around all night. On any other night, I would film these magnificent fish for the entire dive, but tonight I have work to do. This is my 4th night observing the coral and my last chance to capture the coral spawn. I examine a coral head and I can see swollen polyps filled with big blobs that look like eggs. They're actually called gamete bundles. I get ready with my camera and wait. The big moment is definitely coming soon. There, the colony has released its bundles. Since most corals are hermaphroditic, the bundles contain both eggs and sperm. They float up into the water and separate. This allows eggs and sperm from different coral colonies to mix together and cross-fertilize in the water column. They all release at the same time in order to overwhelm predators that come in to feed on this nutritious food source. Soon the water is filled with coral spawn. Not all corals are hermaphroditic, though. Some are gonochoric, meaning they have separate male and female colonies. The male colonies are easy to spot. When they release their sperm, it looks like they're smoldering. I train my camera on a big colony of greater star coral and wait. In spite of my camera's lights, it spawns, releasing clouds of sperm into the water. While I'm waiting for this coral to spawn, a tarpon passes by, checking out what I'm up to. Once all of these eggs are fertilized, they will drift in the current for a while and eventually settle down. If they're not eaten, and if they don't settle into water that's too deep, or land on sand where they can't anchor themselves, they might land on a nice hard surface and take hold. A new coral colony will start growing. After several hours observing the coral spawning, it's time to head to shore with our mission accomplished.
What an amazing spectacle. Millions and millions of coral polyps all releasing their eggs at the same time, synchronized to the phase of the moon. I mean, just an astonishing thing to see, and it just goes to show you that patience pays off, because our perseverance over several nights finally resulted in nature giving us an incredible show.
As I exit the water and head for a hot shower, I'm thrilled to have witnessed one of nature's secret spectacles. It was worth all those long nights of diving, but now I'm ready for bed.